Hey guys, today we are going to start our statistics unit. So it is a very large unit and we're going to break it up in half. So that's why it's called 8A, then we're going to call it 8B. So the first one's going to be statistics and the second half is going to be more data and more kind of a preview of what you might see if you ever take AP Stat. So we're going to start very basic. A lot of this you might have already seen before in your previous classes. So it's going to start familiar, and then of course we're going to start introducing some new topics. Okay. So the first thing we're going to focus on today is all the all the measures of center. And then the next time we're together, we'll do all the measures of spread, and then we'll just do a quiz on just that. Okay, measures of center and spread. And then we'll get into the types of surveys, experiments, and observational studies. And then we'll do some things with that, and then we'll test at the end. Okay? So there will be two statistic tests, technically. We're breaking them up. All right. First thing we're going to look at is we're going to look at the shapes of distribution. So when I collect data and I graph them, there's certain shapes they can give me. Okay. The first one is symmetric. So if we're doing, and usually they're given to us in like histograms or bar graphs. So if something is symmetric, that means it's going to be evenly shaped on both sides. So I can cut it in half and it's the same on both sides. All right. Uniform is going to be if they're all about the same, right? It makes sense if you have to wear uniforms to school, they're all the same. My cheerleaders have a cheerleading uniform. It's all the same thing. Okay? So uniform means they're about the same. It might not be exact. It might be very close. Okay? But it will look something like this. They all look about to be the same thing. Okay? Skewed right versus skewed left. Okay, so this is going to be where my data is kind of leaning towards one side. Whether it's skewed right or skewed left is going to be where the tail of the information is. So if we're skewed to the right, my tail, most of my data is actually going to be bunched together on the left, and then it's going to skew off to the right-hand side. So it's going to start low. We're going to have a bunch of data on the right side, and then it's just going to slowly kind of skew off to the right side. If I were to like trace this, most of my data, it's not the color I wanted. Thank you. Most of my data would be over here, and then see it would kind of trail off to the right. That makes it a skewed right. Okay. Skewed left would be the opposite. So here, most of my data is bunched together on the left-hand side, and then it's bunched together on the right-hand side, and my tail of it, or the skewness, is going to happen on the left side. So it's going to start small, and then most of my data is going to be over here, and then very little data on this side. So if I were to trace this, it would start low, and then it would increase dramatically. So this is skewed left. So it's looking for the tail. Okay, so skewed right, skewed left. Look for the tail of the data. Okay. If something is bimodal, that means it's going to have two peaks. So like bicycle, we have two wheels. Bimodal means we have two even peaks happening. So you might have some stuff in the middle, and then it's off like that. So this has two peaks out of the same, right? And then if we have an outlier, so we're going to be skewed right, so it's going to look just like the one above. Most of my data is going to be bunched together, and it's going to trail off to the right, right? And then there's going to be some random piece of data just out there. Okay, so this is skewed right, and then it has an outlier on the side. Okay, so these are different shapes of data. Excuse me. Where's my mouse? There it is. Okay. Whatever, it's not working. All right, we're going to go to the next page. I want you to pause the video. I want you to try to match these up with which is which. So A, B, C, D, E, and F. I want you to match them with their description on the side. Some of them could be used in more than one, and some of these have more than one answer. So pause the video and see if you can match things with where they belong. All right, guys, check your answers with mine. So our symmetric graph, graph B is the only one that is symmetric. Remember, it doesn't have to be perfectly symmetric, okay? It's going to be about symmetric, as close as we can get, because not all data is perfect. Almost none of our data is perfect, okay? So this is the closest thing to symmetric. Uniform, what they all look about to be the same, that would be graph A. If something is skewed right, so we're looking for something that has a tail off to the right-hand side, that would definitely be graph D. Skewed left, so having data that is skewed off to the left, definitely C, and people could argue E. So E is kind of up in the air. C is a definite. E, I could take it or leave it. F, bimodal, for sure. It has two different peaks happening in its graph. And then the pieces that have an outlier, so C has an outlier right here, there's a gap. D has an outlier, and E has an outlier. So one could argue that if E didn't have an outlier, that graph would not be considered skewed. So if the outlier wasn't there, you could argue, what, possibly symmetric if the outlier was not there. So yeah, that's how we do. So those are the shapes. Now let's get more into the measures of center, okay? So measures, of central tendency. So which center should we use? So we have mean and we have median that we're going to be looking at, okay? So because the median considers only the order of values, it is resistant to the values that are extraordinarily large or small, okay? It simply notes that they are one of the big ones or one of the small ones and ignores their distance from the center, okay? So would the outlier 100 affect the median or the mean more? Well, if we change and it's referring to these examples below us, okay? If we changed the 100 to a 1,000, would our mean change? Would the median change? So let's see. Let's see what would happen, okay? So we're not going to answer those questions just yet. So first one, we have a set of data, 1, 2, 3, 3, 7, 10, right? We're going to find the mean. The mean is the average, okay? Mean is an average. So you add up your values and you divide by how many you have. So we have 1 plus 2 plus 3 plus 3 plus 7 plus 10, right? I'm going to add those together. I get 26, and I had 1, 2, 3, 4, 5. I had 6 different data entries. So 26 divided by 6 gives me 4.3. The median, or the middle, so in the middle of my values, which is right here, right? So what's in between 3 and 3? Well, it's just 3. So that's what we got going on there. So which one is larger? In this case, my larger of the two is going to be our mean. All right, so now let's see what's going to happen if I change it to 100, if I change it to 1,000, and then we can answer the questions, okay? Would an outlier of 100 affect the mean, the median, or the mean more? Let's see. So now I have almost the same numbers, but now 10 has been changed to 100. So I'm going to go back, add my values together, but instead of plus 10, we're going to plus 100. That's 116. Divide that by 6, and I get 19.3. My median did not change. Look at that. So did it affect the median or the mean more? It affected the mean more because it's pulling in a different direction. My middle number of 3 is still the middle number of 3, right? Okay. I'm actually going to get rid of this because I'm going to need it later. Okay. My last one, so if we change the 100 to 1,000, is the mean going to change? Is the median going to change? Let's see. You probably have your predictions, but let's calculate it. So 1 plus 2 plus 3 plus 3 plus 7 plus 1,000 gives me 1,016 divided by 6. This is going to give me 169.3, and my median, or my middle number, is still 3. So did the mean change? Yes, it did. Did the median change? No, it did not. Okay, so when we create outliers, it's going to pull the mean a certain direction. Okay, it's going to pull that mean closer to that outlier. So my outliers were bigger. So notice it made my average or my mean, it made that also bigger. So it's pulling it that way. All right. So now to choose between which measures of center to use that's the most appropriate for a set of data, okay, we have to look. If it's symmetric and there's no outliers, okay, so nothing is pulling it in any direction, then we want to go with our mean. Okay, the mean really is the best if we can use it. So no outliers. Come on, here we go. No outliers. It's a symmetric piece of data. We're going to use the mean. So my first one, it was pretty symmetric. There were no outliers. So we would use the mean as the best measure of center for that data. Okay. However, if we are skewed or if we have outliers, then we need to actually use the median because remember my mean the outlier pulls the mean a certain way. Okay, and it's skewing the data. It's not making it as accurate. Okay, 19.3 does not represent these values very well. Okay, 3 being the middle, that represents the median the best. Okay, so if we are skewed with outliers, then we're going to go with the median being our best measure of center. Okay, so we are symmetric, no outliers, we go with the mean. If something is pulling my mean away, then I don't want that. It's being altered, so we're going to stick with the median. All right. Here we go. Here's a little make you think question. Here we go. All right, so personal question. At the end of the 6 weeks, if your test grades were 100, 100, 90, and 60, would you rather that I report the mean or the median, to your parents on my progress report? And would you feel the same way if your scores were a 60, a 68, a 60, and 100? Okay, so let's figure out my mean and my median. So which one would you rather me report to your parents? All right, 100, 100, 90, and 60. So again, to get my mean, we add those up, and there's 4 pieces of data. So 100 plus 100 plus 90 plus 60. Divide that by my 4 data entries. I get an average of 87.5. The median, so my values, they are in order. Okay, we look for the middle. So what's in between 90 and 100? We can do 90 plus 100 divided by 2. We get 95 as my median. Okay, so which of these would you rather me pick? You would rather me pick the median, right? Because this outlier of a 60 is pulling your average down. Okay, that's what outliers do. It's pulling your average away. So you would rather me give the median to your parents, your median test score. Over here, we have an outlier again. So do we still want the median or now do we want the mean? Well, now we have 60, 68, 68, and 100. 60, 68, 60, 68, 68, and the 100. Divide that by 4. Our mean or our average for this one's going to be a 74%. Okay. Our median, so we look in the middle of my data, right in the middle. So what's in between 68 and 68? It's just 68. So now you would want me to report the mean average to your parents, okay? Because if the outlier is really high, like at 100, it's pulling your average up, okay? But if the outlier is really low, it's going to pull your average down. That's what actually happens in y'all's classes. When you make one bad grade on a test, it pulls your average down, right? But if you also make a great grade on the test, it lifts your average up. So this is why. Okay, that's outliers. Okay. All right, so now we have a data that was given to us that wants us to describe the shape. Then we're going to find the mean and median of my distribution, and we're going to determine which measure of center we are going to use best. Remember, if there's no outlier, we want to use our mean. If there is an outlier, we're going to want to use our median. Okay, so shape. First things first. I'm going to kind of outline this. So it looks like it kind of goes up I'm not tracing it very well. It goes up, it drastically falls down, it's almost flat, and then we have another little piece over there. Okay? So how would I describe this? Well, I would definitely say skewed, right? I have a lot of data on the left, it falls off to the right, so this is definitely going to be skewed right. And we have this random dot over here at the 90, so we're going to say with an outlier. So this is skewed to the right with an outlier. All right, let's find the mean of this data. So I have to add all my values together. I have a bunch of dots. What are my values? Well, I have 3 60s, right? I have a 65, and I have a 90. That's how we read my data. So we're going to add those together. 60, 60, 60, plus 65, plus 90. And I'm going to divide that value by my 5 data entries. So I have a mean of 67. So I added them all up, and I had 335 divided by my 5 entry points. All right, median is going to be the middle number, right? So I have 5 points, so my middle value is 60. Mode, we haven't done that yet today, but you know what mode is. Mode is the most. So which value occurs the most? In this case, we have, it's in my dot plot, also the highest, the one with the highest dots. So my mode is 60. Okay. So according to this information, which measure of center should I use? Well, I had an outlier. So because I have an outlier, it's pulling my mean a certain direction. We're going to want to use our median. Okay? Because we have, so the answer of why? Because we have an outlier. And it was skewed, right? So both are issues, being skewed and having an outlier. They're both things we don't want. All right, let's do another one. Maybe, here we go. I would like for you to pause, actually, and I want you to try this one. So go ahead and pause the video, try this the way we just did the last one, and then come back and see. All right, check your answers with mine. How did we do? The shape of this is perfectly symmetric. My data points are 70, then I have 3 75s, then I have an 80. I added those up, divided by 5, I got a mean of 75. My median, the middle number, is also 75. And my mode, which number occurs the most, was also 75. So no matter what measure of center I choose, it's going to be 75. But if the best measure of center is going to be the mean, that's because we have symmetric data and we don't have any outliers. All right. We good? Now we're going to get into the weighted average, how to find the weighted average of some data. Okay, so lots of times we have frequency tables where it shows the data like this. A weighted average is a mean calculated by using frequencies of data values. Okay, so this is showing us 30 movies, okay, that were rated. If I wanted to find the average of all these ratings, I would do the weighted average. So I had 8 ratings of 4 stars. I had 12 ratings of 3 stars, 7 ratings of 2 stars, and 2 ratings of 1 star, and 1 rating of no stars. So 8 ratings of 4 stars, that's technically what? A total of 32 stars, right? So we add them together. So 8 times 4 plus 12 times 3, so our frequency times the rating, plus 7 times 2, and so forth. We get a total of 84 total stars divided by my 30 ratings, and we get an average of a 2.8 stars. Okay? So not like the best movie. Okay, so this is called a weighted average. There we go. All right, so now we are going to use a frequency table to create a dot plot and to create a histogram. And we're going to find our weighted average, and we're going to find our median and our mode. Okay, so we have, let's see here, make a dot plot and a histogram of the data displayed in the frequency table, then calculate its mean and median. All right, so we have the value of 2 that is being represented twice, so that means I'm going to have 2 dots on top of my 2. 3 is going to have 3 dots because it has a frequency of 3. I should make these smaller, shouldn't I? So 2, 3, 4 is going to have 4 dots. 5 is going to have 7 dots. 1, 2, 3, 4, 5, 6, 7. And 6 is going to have 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. All right, to do my histogram, we're going to do the exact same thing. It should have the same shape as our dot plot. It's just going to be connected bars instead. Okay, so 2 had frequency of 2, 3 had a frequency of 3, 4 had a frequency of 4, 5 went up to 7, and then 6 went up to 10. So notice my shape is the same, and if I were to describe this shape, I would call it skew to the left. Okay? Skewed left. All right, so let's find my weighted average. So what we're going to have to do, I'll come down here a little bit. So we have my value of 2 occurring twice, plus my value of 3 occurring 3 times, plus my value of 4 occurring 4 times. Oops, I forgot my plus sign. Plus my value of 5 occurring 7 times, plus my value of 6 occurring 10 times. Now we divide it by our total number, okay? So how many frequencies, I add all these together, you actually get 26. So we're going to divide all that by 26. All right. So when this happens, type it in your calculator, guys, exactly as you see it. 2 parentheses 2, plus 3 parentheses 3, plus 4 parentheses 4, plus 5 parentheses 7, plus 6 parentheses 10. I mean, you can type it in just like that if you want to. Push enter, I get 124 divided by 26. And I get a weighted average of 4.77. What's that one? All right. Now my median, so in the middle, so I'm looking at my dots. If I have 26 dots, what's the middle? Well, it's going to be in between dot, 13 and 14? Because 26, if I break it in half, it's going to be 13 and 13. So I got to look in between dot 13 and dot 14. So here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, look at that. Both of those are going to be with my 5. So my median has to be 5. Mode is the number that occurs the most. So which one of these has the highest histogram bar or the highest row of dots? And that's going to be my value of 6. So if this were like movies and ratings, then the average rating of these movies would be a 4.7, okay? The median would be a 5, and the mode would be a 6. So the most people made it a 6. All right. Come on. There we go. Okay, so now with probability distribution, here we have a two-way frequency table, but this is expected value. The division is already built into it, so you don't have to do the division part, because notice it gives it to me as a probability, which we just did a whole thing on. It already has fractions, which means it already has division. So all I have to do is find the average of those. Okay, so I have to just do, I just have to do the multiplying. Just have to do the multiplying and adding piece. I don't have to divide. So my expected value, this is number of free throws that they throw and the probability of making those free throws. So 3 out of 20, 3 out of 20, 1 out of 5, 1 out of 2. So we're going to multiply that with the numbers they actually did. So they made 0, the probability of 3 out of 20. I'm sorry, making 0 has a probability of 3 out of 20, plus making 1 has a probability of 3 out of 20, plus the probability of making 2 of them is 1 out of 5, plus the probability of making 3 is 1/2. So we multiply those together, and then we add them all up, and then we get our expected value, we expect 2.053 free throws. So I could predict that this person is probably going to make at least about 2 free throws when they throw it. Okay, so let's do one like that. Let's do an example of the expected value. Here we go. All right, so the probability distribution for the number of free throws that Larry makes in a game is given below. Find the expected number of free throws that Larry makes in a game. So that we're going to predict how many free throws is Larry expected to make in a basketball game. Okay, they gave me number of free throws. They gave me probability, decimals, fractions that already has the division built in. So to fill this one out, we're going to take a number of free throws, multiply it by the probability. So 6 times 0.58 plus 7 times 0.14 plus 8 times 0.07. Okay. Put that in our calculator. Here we go. Add all of those up, we should get 6.07. So Larry is expected to make 6.07 free throws in a game. So he's expected to make about 6 free throws. Okay? So I want you to use what we just did. I want you to pause the video and I want you to do this one. The probability distribution for the number of pieces of junk mail that May receives is given. Find the expected number of junk mail letters that May receives in a day. I want you to pause and I want you to try this one. All right? Go ahead and pause. All right, so here we go. You should have gotten that May can expect to receive 2.05 junk mail letters a day. So I've showed how I set it up. When you multiply and add them all together, we get the 2.05. So remember, if it's not given to you in a probability format, like the movies and their ratings, you will have to divide out the total. If you've given the probability, so whether it's in decimal or fraction form, the division's already built in and we don't have to worry about it anymore. We just have to do the multiply and add piece. Okay? All right, our next pieces of measures of center are going to come from box and whisker. Yeah, this is still measures of center. So we're just going to kind of remember what box and whisker is. We're going to work with this more, especially with our measures of spread. So we're going to be reintroduced to what box and whisker is. I promise you did this in Algebra 1. We're going to do, I think, 2 examples using this, and then we'll be done for today. All right? So box and whisker, the quartiles are the medians of the lower and upper half. So if I took the first half and cut that in half, there's my first quartile. My last half, cut that in half, that's my third quartile. Okay? If there is an odd number of data values, then we don't include the median in either half when we figure things out. Okay? So we have our Q1 median and Q3. Our median can also be called Q2, technically. Okay? So quartile means what? A fourth, right? So the first 25%, then it's the next 25, then it's the next 25, and then we're done. The piece in the middle between Q1 and Q3 is called our interquartile range. It's my middle 50% of the data. Okay, so to get from Q1 to Q3, that's 50%. That's my middle 50%. That's what creates our box. Then we have dots for a minimum and a maximum, and that's going to be our whisker. Okay. So let's make one. Again, this is Algebra 1 stuff, but we're just going to have to review because we're going to work with these a lot. So make a box and whisker plot to find our interquartile range. Now, if you have one of these calculators, and I strongly suggest that you do, okay, you're going to use this to get all of these data values in your calculator instead of having to do everything by hand. Okay, so if I have a calculator to be able to do this, and remember, if you need a free app like this, if you have an Android, download this app, Wabbit EMU, okay, on your Android phone. Oh, that's not it. It has like a little calculator with a little rabbit on it. It's free, and it is a TI-84 graphing calculator, okay? And it's completely free, and it's on your phone, right? So Android people use that. iPhone people, I think you have to pay for it. I think it might be $5, which is better than what 120 that these are. I know Desmos is out there also. I'm just not an expert at Desmos. I'm an expert at this. So I'll show you with calculator. I can also show you by hand for today, but then after today, I'm going to be doing it all in my calculator to get the information. All right, so we have our data points. So step one, put our data in. So you're going to push our stat button, which is right here next to the arrows. It says stat. Okay, we get this window. We're going to go over to edit, which is already there. We're going to click edit. All right. This is where we're going to put our data entry into. So my list 1 is going to be the values given to me. So I'm going to push 6, then push enter. 8, 7, 5, 10, 6, 9, 8, and 4. Okay, so I have my list of values. All right. Now to get my information, I'm going to quit. I'm going to leave this. I'm going to go back to stat. There we go, which is the button next to my arrow. This time we're going to go over to the calculate header, and we're going to do the one-to-one variable stat, which is the very first one, and we're going to push enter. And if you notice, and then just keep pushing enter, go to calculate. There we go. So now here's all of my information. So it tells me what I need. So if I scroll down, look at that. It even has it in order for me. Minimum, Q1, median, Q3, and max. It's all there, okay? And you're really going to need this because that stuff at the top, we're going to use that also. That little X with a bar on top of it, that's your mean. My mean is 7. When we get to measures of spread, we're going to use that little circle thing with the hat on it. It's called standard deviation. All right? So please try to get one of these or get one of the apps on your phones because we're going to use this a lot. Okay, so when I look at this, what do we have here? I have a minimum of 4. I have a Q1 of 5.5. I have a median of 7. And I have a Q3 of 8.5. And I have a maximum of 10. To create our dot plot, I'm just going to go 4, 5, 6, 7, 8, 9, 10 because my lowest number was a 4 and my highest was a 10. That's how I picked those out. Nothing fancy there. So my minimum gets a dot. Q1 of 5.5 gets a line. 7 gets a line. 8.5 gets a line. There is my middle box for my box and whisker. Maximum gets a 10. And we connect. Okay. To do this by hand, I will show you one time, and I'm not doing it again because why when I can use this? So to do it by hand, you have to put them in order first from least to greatest. So what do we have? We have 4. Then we have a 5. Then we have 2 6s. We have a 7. We have 2 8s. A 9 and a 10. Okay, put them in order. 1, 2, 3, 4, 5, 6, 7, 8. So 9 values. So we know this is our minimum, right? Here's our maximum, so we got those. We're going to cut it in half first. So when I cut it in half, that's 9 values. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So if I take my fingers and I put them on the 4 and the 10, the 5 and the 9, 6 and 8, 6 and 8. I'm left with 7 in the middle. All right, so this is my median. All right. Now to find my Q1 and my Q2, I'm sorry, and Q3, remember, if there's an odd number of data values like I do, then we don't use that to find my other quartiles. So now I'm looking for what's in the middle of 4, 5, 6, and 6. Well, in the middle is going to be in between 5 and 6. What's in between 5 and 6? 5.5. There's my Q1. Here, 8, 8, 9, 10. What's in the middle of 8 and 9? Well, that's going to be 8.5. And that's going to be my Q3. Sorry, my pen is not looking very nice. There we go. That's better. Okay, so that's how we do it by hand. I don't like doing it by hand because I can do it way faster on my calculator. Okay, so again, download the app. If you're an Android person, it's free. If you're an iPhone person, it might cost you a couple dollars. Talk to your parents, obviously, before you buy it. But I think if you can get it on your iPhone for like $5 or cheaper, again, better than the 120 on this. All right. All right, we're going to do one more, and then we're going to be done. Okay. One more with our measures of center. And then we'll be complete for today. All right, so here we're going to kind of bring everything together. All right. So I have a dot plot given to me. It wants us to find the 5-number summary. So my median Q1, minimum Q1, median Q3, and my maximum. We're going to create a box plot. Okay. So when I plug my values in, okay, well, what do I have? I have, I'm going to put it over here. We have a 75. We have an 80. We have an 85. We have what? 4 90s? Okay. So if you're doing it by hand, you can already see your minimum and maximum. I can go ahead and put that on here. I know my minimum is 75. I know our maximum is 90. Okay, so I know we're going to go 75. I can go ahead and count my 5. 75, 80, 85, 90. Okay. So I'm going to use my calculator. I'm going to push Stat and Edit. To clear the list I already have in here, you're going to push the up arrow to highlight the L1, your list 1. You're going to push Clear, and then you're going to push down, and they're all gone. Do not push Delete. If you push Delete, all of list 1 just disappears. Don't do that. Clear. Clear your list. Do not delete it and get rid of it forever. Okay? Clear your list. All right, my values, 75, 80, 85, 90, 90, 90, 90. All right, so I have all of my values in my list. I'm going to go back to Stat, go over to Calculate, and do one variable Stats. I'm going to Calculate, and it gives me my 5-number summary at the end. I have a minimum of 75, which I already have. I have a Q1 of 80. I have a median of 90 and a Q3 of 90 and a maximum of 90. Okay, so let's see what this looks like. I'm gonna move my face over there. Okay. So minimum gets a dot, right? Q1 gets a line. Median gets a line. Q3 gets a line. And my maximum gets a line. So it looks something like this. Now, why does it, whoop, I'm sorry. Why does it look like this? Well, wouldn't you say our data is skewed? Right? All of my data was kind of clumped over. So this was skewed, what, to the left? So look at my box plot. My whisker is the only thing on the left-hand side. All my data is bunched together on the right. Okay? So this is how a skewed box plot would also look. All right? So let's compare these two, the dot plot and the box and whisker of the same thing. Let's compare them together. So what do we see with a dot plot that we can't see in a box plot? Excuse me. Well, I can see mode, right? I can see mode in my, sorry. Come on. What are we doing? Thank you. I don't know what's happening over here. Okay. There we go. I can see mode in my dot plot. What else can we see? We can see frequency, right? How often a number occurs. I can't see that in my box and whisker. And I can also see how many total data entries we have. Total data entries. Okay, I can see exactly how many of each I have and the total I have. I can't have any of that in my box plot. All right, so now what do I see in just my box and whisker that I can't see in my dot plot? Well, I can very easily pick out my Q1, right? We can very easily pick out our Q3. We can very easily pick out our median from our box and whisker. And we can also find the IQR, our interquartile range, or that middle 50% of my data. It's easy to pick out in my box and whisker. All right. What can we see in both of them? Well, in both of them, we can clearly see a minimum and a maximum, right? Those are clearly labeled in both kinds of graphs. I can get my full range on both dot plots. I'll move this over here. Okay, we can get my full range. So because that's what your maximum minus your minimum. So if those are easy to see, then I can easily find my range. And lastly, we can see the shape in both of them. So they both showed a skewed shape. All right, so that is all of your measures of center. I know it's a lot. You're going to have a worksheet to work on. This is going to be what we're going to be kind of dealing with the rest of the year with statistics and data and stuff like this. If you have any questions about anything that we are currently doing, if you need help with calculator stuff, reach out to me. But you can also go back earlier to this video and rewatch how I put those first entries in. All right, remember, always clear your list, never delete your list, always clear. But anything I'm doing on this calculator, I can do on the app that's on my phone at the same time. All right, so go ahead and work on your worksheets, and I'll see you guys next time.